Greetings and welcome to a tutorial on loops in Java. Now, they're not too complicated, although they are a little bit different, especially the for loop, from what you are used to in Python. So let's take a look at this. So first up, the for loop. This is the one that is considerably different, both in syntax and in intent, between Java and Python. In Python, a for loop is expressly designed to iterate over a collection. That is all that a for loop does, is iterate over a collection. That is its sole job in life. In Java, that is not at all what the for loop is designed for. A for loop is designed to repeat an action a certain number of times until a condition is false. Now, for a for loop, we've got a very important structure here that we have to obey. So we have the for keyword, open and close parentheses, and then we have three code statements. The first code statement is the initializer. This will always run before the for loop executes. This code statement can be anything. It can be an equation. It can be declaring and initializing a variable, which is what you will most commonly see. It could be some complex formula. It doesn't matter. As long as it is a single executable statement, you can go in the initializer. The second portion, tooltips, stop being helpful. The second one is the conditional. Before the loop runs, this conditional will be checked and it must be true. This does mean that you can set the conditional up such that the for loop will never run. It's also possible to set the conditional up so that the for loop runs forever, which you really do not want to do. Again, this is any statement that can be evaluated to true or false. Complex equation, a function call that will return a Boolean, doesn't matter as long as this middle statement can evaluate to true or false. The final statement is what happens at the end of a loop. Once you reach the end of the code block, which, as per usual in Java, is defined by curly braces, once you reach the end of the code block, this end statement will execute, and then it will check the conditional to see if it should do another run of the loop, and so on and so forth. Once again, this end statement can be any executable statement of code. Function call, complex formula, whatever it is you want to put in here is fine. Now, the form that I have my for statement in right now is kind of the traditional for statement. It is the for statement that you will see most often. I am initializing a variable. I is a very traditional variable here, short for index. And I'm going from 0 to I less than a number, and I am incrementing it by 1. That's, again, this is the plus plus operator, or increment. I could also write this as I equals I plus 1. I could also write it as I plus equals 1. Any of those statements would be correct to put in here. To show it in action, we hit run. I'll tell it I want table for 5, and there we go. And see I is going from 0 to 9 and generating our multiplication table. To demonstrate that a for loop can be set up such that it will never run, I'm going to change the initialization to 10. So I is going to be initialized to 10, but 10 is not less than 10, which means nothing happens. The for loop does not run because the conditional is never true. Therefore, no iterations. Now you are not limited to counting up by 1. Again, remember, you can put in here whatever you want. So maybe I want to go, instead of 0 to 9, I want to go from 9 to 0. Fairly simple alteration. I change it to I equals 9. For my conditional, greater than or equal to 0, because I want to include 0. If I did I greater than 0, I would exclude 0. And instead of I plus plus, I will use the decrement operator, I minus minus. Or I could do I minus equals 1. Run the code. There we go. We can see it goes down from 9 to 0. Changing it back to the more traditional form here. If you have an array, assuming I can type correctly, if you have an array, this is the code that you will most commonly use. We'll deal with arrays next week. But again, like in Python, index starts at 0. So if I have a 10-element array, this is going to go from 0 to 9, which is the valid index range for a 10-element array. We'll look at arrays next week. Continuing on, let's take a look at while loops. And if in case you have forgotten, if you go to edit, you have control plus / toggles line comments on and off. A while loop in Python and Java are pretty much identical in logic, just very minor variation in syntax. We have the while keyword, open and close parentheses, a statement that needs to evaluate to be true or false. You define the code block using curly brackets, and then whatever statement needs to execute in here. And the while loop will continue to execute until this statement is false. Remember, the difference between a for loop and a while loop is a for loop, you know when you need to stop. Even if you don't know it when you're writing the code, when you get to this point in the program, like you can determine, it's like, okay, I check the size of this array. Oh, this array has 15 elements. Okay, well, that's the number of times I need to run. You know how many times a for loop needs to run. A while loop, you do not know how many times it needs to run. It might need to run once. It might need to run 15 times. It depends on the situation. And that's when you use a while loop. Reading to the end of a file, allowing the user to do an action until the user decides they don't want to do the action. These are the types of things you use while loops for. And of course, a while loop can be configured so that it never runs. I have set kill the loop equal to true, but the loop only wants to run if kill the loop is equal to false. And so if I run this code, by the way, as a quality of life issue, as our code gets longer, instead of having to scroll up and click on run, when I'm further down in a file, I will typically come over here to the file list, which again, the Explorer, and right-click on the file in question and select run or debug, depending on what it is that I am doing. Again, we got first loop done, meaning this did not get executed, not even once. Which brings us to the do while. Now, this is not something that Python has. You can mimic it, but Python does not explicitly have a do while structure. Syntax on this one's a little bit different. So we have the do keyword. There's no parentheses on this. Do not put an empty set of parentheses. It's just the do keyword. You have curly brackets defining your code block. And after the closing curly bracket, this can be on its own line, by the way. You can write it like this. I greatly prefer to keep my while on the same line as the closing curly bracket. You have the while loop with a semicolon at the end of it. Make sure you do not confuse this. A while loop with the while keyword at the top does not have a semicolon at the end of it. Do not put a semicolon at the end of a while loop. But for a do while loop, you do need the semicolon at the end of the while statement. Make sure you do not get these two confused. The difference between these is that a do while, the check is done at the end of the loop, versus a while loop, the check is done at the beginning of the loop. So a do loop is always guaranteed to execute at least once. Now, how often will you use a do while loop over a while loop? That is 95% programmer preference. There's been a few times in my programming career that I've been like, yeah, okay, it makes sense to use a do while here. For the most part, I just structure my while loops and the conditions surrounding the while loops to have them work the way that I want them to work. If I always want to make sure the while loop executes at least once, I'll make sure that I initialize the starting variables such that the while loop runs at least once. This is primarily a matter of programmer preference, but for the most part, you will not see do while loops very often. They are part of the language. You do need to know they exist, but they aren't particularly common to see. And to see it in execution, if we run the code, first loop done. Second loop, did I show? Yep, yes you did. So again, the do while loop executed once, hit the check. Oh wait, kill the loop is not false, so that's going to fail. And so we stop the loop and it only executes once. Last thing to take a look at, if statements and switch statements. Also, block comments. Anytime in Java you see this /* and then eventually a */, this is what's called a block comment. Everything between those two symbols will be considered a comment. So you can see all this text has been greened out because it is inside that block comment. Is it functionally any different from using the keyboard shortcut to highlight a chunk of code and toggle on and toggle off line-by-line comments? No, it's functionally identical. Personal preference, I will generally tend to use block comments when I've got a large unified chunk of code, or if I'm putting in several, like a paragraph's worth, multiple lines worth of comments on something, I'll typically use a block comment style then. All right. If statements, again, largely the same as to what you're used to in Python. There's some syntactical differences. We have the if keyword, open and close parentheses, statement that evaluates to true or false. Curly brackets to define the code block. And then optionally, if I have additional checks that I want to make, I can put in as many or as few else if statements that I want. And then if I want a default condition that will always run if everything else is false, I can put in an else statement. The exact same logic. I can have an if, I can have an if else. I can have an if, else if, so on and so forth. It works exactly the same way. If this is true, nothing else will be checked. Flow of execution will continue on after the final part of the if chain. If this is true, again, nothing else will be checked. It just goes on down. And else, if you reach an else, the else will always be executed. Exact same logic as what you had in Python. But we got something weird down here, something new and strange. The switch statement. These are legitimately strange. These are one of the odder constructs that you will encounter. They are not very commonly used. In fact, some modern languages, don't even define a switch statement. Python, for the longest time, did not have a switch equivalent. As of one of the earlier Python 3 updates, it did put in a match statement, which is very similar to a switch, but you will almost never see that in Python code. It didn't exist, like I said, until one of the Python 3 updates. Switch and if statements pretty much do the same thing. So we look at this code, we're going to prompt the user to choose a 1 or a 2. Also notice that the scanner, I didn't point this out explicitly, but the scanner does have the ability to grab and automatically cast strings to numbers. So instead of saying next, I'm saying next int. So we're grabbing an integer from the user, checking to see if it's equal to 1. If it is, print out their choice. If it's equal to 2, print out their choice. And if they didn't do any of those, wag your finger at the user and say, that's not what I asked for, user. And it runs exactly like you would expect. So let me just comment out the switch statement here real quick. So we are just looking at the if. Right-click Run Java. Clear out the multiplication table. There's our loop stuff. Choose 1 or 2. I will choose a 3 because I am a rebel like that. And I'm told that that's not what was asked for. As expected. Now, if I take out the comments on the switch statement and I let it run, take out the ifs, and once again, I will choose a 3. That is not what I asked for. It does the exact same thing. So what's the point? Why would I use a switch over an if or an if over a switch? 90% of the time, this is a programmer preference choice. They do the same thing. There are a few scenarios in which you would choose a switch over an if or an if over a switch. Switches are really good for configurations, especially if you have odd setups where you have, if one configuration is true, there's a chance that you might also still want to do a different configuration. So let's take a look. Before we get too deep into the weeds on that, let's take a look at the structure of the switch statement. So we have the switch keyword, open and close parentheses, and then a statement. This has to evaluate to a value. Because what happens, and then we have our curly brackets defining our code block, is then we're going to use the case keyword and put in a value here. Basically, what this is saying is if target is equal to this value, or if target is equal to 1, then I'm going to execute whatever code is associated with this case. Notice the syntax here is a little bit weird. It doesn't quite follow the pattern that we've had up until now. Case, after the case statement, you have a colon. This is very important to notice. It is not a semicolon. It is a colon. and there are no curly brackets defining the code block for the case statement. It is also worth noting that the indentation here means nothing. In fact, again, please don't ever actually do this. But you can have everything on one line. The indentation does not matter here. Still works. How it knows when the case is done is by the break statement. Now, if you've done your reading, you will know that break is used to terminate loops. So you can put a break in a do loop, do while, a while loop, a for loop, what have you. Break will get you out of it. In more general terms, a break statement will break you out of your current code block. To a point. Don't try to use a break statement to get out of a function. That's not how it works. But in the case of code blocks, if you have a break statement, it will break you out of that code block and allow you to continue execution. And that's what's happening here. If case 1 is true, we do system.out print, we hit the break, we jump down to here, execution continues on. Case 1 is false, okay, we'll check case 2. Case 2 is true, do this, hit the break, jump out. Default is sort of like the else for a switch statement. If everything else so far has been false and we hit the default, we'll execute the default. Notice I don't have a break here because there wouldn't be any point to it. There's nothing else to check after this. The default has to be the last one. And so if you've hit a default, there is no need for a break. You're out of the code block anyways as soon as it's done. Here's the thing, though. We don't have to have the break statement. And this is where switch statements get a little weird and are different from an if. Now, if I enter in a 2, I'm going to do both of these. So I entered in a 2. You chose 2. That is not what I asked for. And, of course, if I give it a 1, it just tells me you choose 1 because we hit the break here and jump out, so the default doesn't get hit. This is why switch statements are weird. If this is behavior that you want, and there's only very specific scenarios in which that is actually correct desired behavior, then a switch statement can potentially be a lot cleaner to write than the equivalent if. Can I do this logic with an if statement? Of course I can. Remember, the question in programming very seldom should be, can I do this? Because the answer is almost always yes. But how much pain do you want to suffer? So, can I replicate this behavior with an if statement? Of course. But if it's a fairly complicated switch statement, and this is the kind of behavior that I need for a couple of different things, then this might be better and a lot cleaner and easier to maintain than an equivalent if statement. That said, the vast majority of time for code, you are going to see if statements over switch statements. It is, like I said, mostly programmer preference. If you like the way switch statements look when you're just like checking a list of values, go nuts, use a switch statement. If you're like, I can't be bothered, I'd just rather use ifs, use ifs. Now, there is a scenario in which you should choose if over switch. And that is if you need nesting. Can you nest switch statements inside of switch statements? Yes, but that's a really horrible idea. Please don't do that. most programmers will agree with that statement. Most senior programmers will agree with that statement that you should not nest a switch statement. That is just bad logic. Redesign your logic if you are trying to do that. However, nesting if statements is very common to a point. Again, if you've got like 4 levels deep of your nesting, rethink your logic. You shouldn't be that nested that deep. But if statements are designed for nesting and work well with it. So if you've got a nested series of questions, you would almost certainly want to choose an if statement, not a switch statement. Quick review to wrap everything up. For loops, 4 keyword, 3 components, initializer, semicolon, conditional, semicolon, end action. Traditionally, you will initialize an integer to 0, set your variable to less than some number, and increment it by 1. But you are not limited to that. Any executable statement can be your initializer. Any executable statement can be your end condition. Anything that evaluates to true or false can be your conditional. You can set it up so the for loop never runs, and that is sometimes desired. You can also set them up so that they never end. That's never desired. A for loop should never have an infinite condition. Period. While loop, while keyword, open close parentheses, some statement that evaluates to true or false. This will always be checked before the loop runs, which means you can configure a while loop to never run. Again, defined with curly braces for your code block. A do while loop is a little bit weird on the syntax. You have do, no parentheses, curly brackets to define your code block, and then a while statement that has a semicolon at the end of it. Do not get these two confused. While loop, no semicolon. Do while loop, semicolon. A do while loop will always execute at least once, and then will check the condition at the end. If statements, if keyword, open close parentheses, something that evaluates to be true or false. Make sure you check the if operators for how you do ors, ands, nots, and all of those other operators. Curly brackets to define code blocks. You have else ifs that you have the option of putting in, and an else if you want to have something that will always execute if everything else is false. If any one part of an if else chain is true, only that one part will execute, and then flow of execution will jump to the end and continue on. A switch statement is an alternative to an if statement. You have switch keyword, open close parentheses, something that will evaluate to a value. Curly brackets to define the code block. And then you will have a series of case statements where you will put the value that you are checking against this statement. So again, you can mentally translate this to target is equal to 1, target is equal to 2, so on. However many lines of code that you want associated with that case statement. And then unless you want code to continue execution, you need to put in a break statement, which will break you out of your nearest matching set of curly braces, which is the switch statement, so that way none of the other cases will be evaluated. If that is not the behavior that you want, you do not have to have a break statement, but be aware that execution continues so that multiple case statements, or in this case, a case statement in the default, can be executed. Finally, you have an option to put in a default statement, which acts like an else. If everything else is false, then the default will execute. That does it for loops and ifs. Good luck on the assignment, and I'll catch you on the next tutorial.